years ago on Conroe Road by linear. We as engineers, as planners, cannot design and plan for worst case. We do design our 85 percentile and such. So for cost reason, such an event as IKEA or opening or the event in Villa Park may happen. And then another reason for it is that we're making certain that developer is paying a fair share for the impact of its development on the infrastructure. So that's basically when we do the design and check level of service on the surrounding road, we make certain that the development does not jeopardize the standard level of service for the particular roadways surrounding the development. And then we are making certain that folks that want to get to that site and get out of that site can adequately do that. That's one consideration. DRI stands for the development of regional impact. Those are defined by Florida statute. I pull out those for the surrounding counties, knowing that your site will be on the 6 counties. That gives you the limit. So what does that mean? If your development is below those limits, you will get a hard pass because your impact is not significant, it's not regionally significant. So that, but for purpose of this course, regardless the size of your development, whether you have 1,000 housing units or a certain square footage of retail, we will do a TIA. So say, hey, my proposed development was below those to Mr. Ray, I'm not going to TIA. No, that's not the case. So let's just rise a bit high altitude and understand what a four-step transportation planning is. First of all, what is the purpose of transportation planning? Transportation planning is an educated guess of future demand, thus helping us design, plan, construct a roadway facility to accommodate that future demand. It's a four-step. It hasn't changed since I was in a school 30 years ago. We still do generation. So what happened? Each area, let's say Metro Orlando area, which is consisted of 4 counties, is divided. Let's just assume that the greater Orlando area. So it gets divided to this homogeneous zone, TAC, traffic analysis zone. And for each zone, based on existing value and future value, we calculate the amount of attraction and generation of journeys. Let's assume this TAC 111 has 1,000 residential housing unit, 2 million square feet of retail. So we will go to the Bible for generation that is published by ITE, the latest version that you got copies that are appropriate to your assignment of 9th edition. And based on the land use, we come up with a number of daily trips and peak period hourly trips. Similarly for retail, whether it's restaurant, what have you, the exact car. So these are generation because they coming out of residential. For the retail, it's attraction. How many people come to the mall, to a shopping street on a daily basis and pick out of. Once we establish that for every zone, for current year and 25-year horizon, then we will do tree generation. So I have a 3-year T that got originated from zone I and wants to go zone J. This computer does that and calibrates and it achieves an equilibrium of every journey that goes from one region to another. So that's step 2. Step 3 is gonna do some calibration and assessment. How many of those will take personal auto, bus, rail, bike, and what have you. So that's what we call modal split. And that could be personal vehicle, mass transit, ferry in some cases and such. Once that is done, then we need to assign those to a specific roadways. So if so many TIJ, so now we know they're coming from zone I, they're going to zone J, they're using mode M. Now which route will they take? If they live in UCF area and they want to go to Dr. Phillips area in Southwest, will they go 408 I-4? Would they go 50 John Young Parkway? So based on a travel characteristic of each route, we do an equilibrium to load every route to a certain operating speed designated at that specific. At the end, we will have a map that shows for every region, every TAZ within a metro area, how many cars go from one area to another area in one road, and then how many people will be riding links on each links route, how many will take Sunray, and such. So that's basically my elaboration on transportation. Going back to the TIA, the way it works as well as the process, if you were hired by a developer to the TIA, you will discuss the development in information and project goal with the project owner and team. That has already been done with your plan. Then you will sit down with the permitting agencies and iron out the methodology. What software you're going to use, what version of which policy you're going to use, what are the road link classification are they going to change. So you basically establish the playing rules that you want, or if there is any justification to modify and negotiate for us for exception or variance due to unique development, you can do that at that point. Then you will do the TIA. Your TIA will go through review, just like your water management permit and such. And then you will meet and come up with any mitigation plan. The mitigation plan could be that you have to widen certain roads within area of influence of your development, or you may have to cut a check for your fair share that corresponds to degree of degradation of the roadway facility that you propose in your development on. So those are two likely outcomes. Let's quickly go through the components of the TIA. I expect to see a nice introduction. In introduction, you need to introduce to me as if I am man from the moon. What are you doing? What is the plan? What is the land? Where is it located? What are the streets network? What you propose there? I do not know that. When I give you TIA, I don't have the luxury of the previous seminars. So I need to understand during introduction, what is that you do? What is the purpose of your TIA? I need to see kind of land use, number of units, and such at that point. Then the next thing is data collection. You need to gather enough data, and I give you the sources for those to build your base case scenario. What exists out there pre-development? Because as you remember, we are evaluating impact. So I need to know basically what was what you adding to it. Then we talk about how it's impacting, right? So it is important. In the existing condition, I need to know what type of facility you're trying into, what is the speed limit, what's operating speed limit, what lane calls, is it 4 lane, divided, undivided, what kind of access type it is, as far as access management category and such. If it's signalized, what are the signal spacing, because those are important in evaluating the impact. So you need to do a total search of the street that you dump into. Then once you establish existing condition, you need to research the plan and program improvement. We will do clip generation, we will distribution just like I showed you at a high altitude, but I will go through each one of those. And then hopefully at the end, at the eighth step, you will have the impact of your development, and if it adversely impact the existing street network, you will do a mitigation plan for it. Lastly, a little bit of geometric work. You need to show me detailed layout of interest your site, including lane width, left turn, right turn, pace, length of them, and those type of analysis. Very important, and the part that is two gentlemen that are practicing engineers who will tell you the thing that people read most in real world out there is that last section. They read that first. So that needs to be comprehensive. That needs to tell the entire story what's short. So that's a very important section as I review your work.
It's 100% true. When I get a traffic study, the first thing I go to is this conclusions. I'll probably go back and read how we got there eventually, but the first thing I want to know is what's the conclusion. If it's a major mistake in the conclusion, it's going to have a big impact on what you think of that study.
To me, I review these things, quite often. My staff prepares them for posting. They're not review, but before the sheet out, I do a final QAQC. I read the conclusion. From conclusion part, I know which part of the report I need to read while DSP himself. So that's the thing. So
which one you can focus on? Which one you can sort of skip and do something about that?
So in the introduction, we will have the project description, relevant development information, site location, Google map, here it is, it's north arrow, here's Orange County, and here's the site, and then you tell me what is the photo of TIA, and then you cite any references, any sites that you gathered the data from, so I can check whether you can relate this data. Data collection, of course, garbage in, garbage out. If you don't get the right data, your analysis is not going to be accurate. And so you will collect the volume on the roadways, what type of median is there, is it paved median, is it striped median, landscape median and such, what is called the speed limit, road access. I expect a sketch of the intersection, number of lanes, left turn, right turn, signalized and such, and then you can pull those out from that side. This is a sample of what you will get. I'm not going to go through every column, but pretty much self-explanatory. You locate the roadways surrounding your development, find them in this column, find the location where they fall, and pull out the needed data. So this is just a sample of a turning volume, 15 minutes interval. Some of these are available for certain intersection within Orange County and FDOT site. Since your site is on a state of 50, your best bet is FDOT analysis. So this shows the condition diagram, both from Google Earth and aerial shot, and then graphically on the left-hand side. You will see that it shows the speed limit on both facilities. It shows the median treatment. It shows the lane calls, and whether the right is a free ride or is a merge ride. So something like that is very valuable. Now, as far as existing condition, we will use several tools to evaluate existing condition. Existing condition means 2014 on the surrounding street. In your case, the state road 50 and the two roads that intersect the state road 50 on each side of your development. You can, based on the turning movement count, use the highway capacity manual to tell you what existing level of service is and what is its correlation with existing standards and requirements for that type of facility. As you know, level of service goes from A to F, with A being good and F being bad, and each facility has a designated level of service standard. As you're in more urban area, there is more tolerance for service failure. So some downtown Miami Street, you can go as bad as level of service B and B. In the rural areas, level of service A and B. In your area, you're going to find out from the chart that I showed you. So there are also DOT handbook, quality and level of service handbook that can give you a higher altitude and more volumetric evaluation of LOS. You can go deeper by utilizing some software, Synchro, that does the actual simulation and such. I don't see it necessary for this site. So here is the FDOT general service volume. You enter it based on your roadway characteristic and with your service flow volume. to tell you level of service. This is a sample of the roadway capacity and level of service analysis. And for each approach, each movement, northbound, southbound, it has tabulated the level of service. That's just a sample. So, as I told you, highway capacity manual is the guideline or the book that helps us define facilities, the level of service. It comes with a software that I'll show you in a second, very user-friendly and window-based software that you can enter the volume and it comes out the level of service for you. As mentioned earlier, there are more complex and micro simulation software, Synchro and others, Vism, that do that analysis, but I don't think your area is that sensitive and your volumes are not going to be that high for micro simulation. And I saw the few have a mistake in this course as well. So this is a HCS input screen. I'm not going to go through every box in data entry. It's very self-explanatory. And when in doubt, you don't understand, there are tools and help that can guide you in entering data. Once you enter the data, the volumes that you collected in the field, name calls that you collected in the field, if you have the signal timing readily available, you can evaluate that operation. If you do not have the signal timing at phasing, it has a provision in the menu to optimize it, and based on that, give you overall level of service. It also gives you the network queue at each approach, and give you each movement average vehicular delay. And by combining weighing averaging those, you will get a total intersection vehicular delay, possibility choosing level of service. That's the output. It gives you just about everything you need, every element that's needed for the achievement. Okay, plan and program improvement. Why is it important for you all to know that? Okay, here we are, 2014, the stage of 54 lanes. Okay, between now and the time you open your development, there could be scheduled widening by FDOT. Okay, if you are not aware of that improvement, that widening, you probably do your analysis based on the 4 lane. And you're going to find out that it's operating at the level of service D, and you just cause it to go to F, and you just cause the developer a book of money for implementation or your fair share of widening. However, if you research Metro Plan, it gives you under CIP, they have a 5-year work program that shows what projects are committed, which means funding has been secured. So by all means, go to that site, metroplanorlando.com, look at the roadway that your project is talking on, and see when and if plan improvement will be in place. Let's assume it takes you 4 years, design, permit, construct. Let's say you're opening it for 2018. If FDOT has a widening in 2017, by all means, use that added capacity for your cost analysis. That's just a sample of the last one. That's how the report cover looks like, and that's where what the inside looks like. Basically, list the roadway from where to where, how long it is, what they do in 5 lane, and what is the various phase of funding, and so on and so forth. Regeneration analysis, I talked about that at the high altitude when I did my introduction to transportation planning. The applicable sheets from that big book have been copied and given to you. So use those. They look something like this. Basically, how they were developed, they were empirical data collected based on a various size land use for each type of land use, and they averaged them out and did a statistical model that estimates the number of daily and peak hour volume generated by that site. So in your residential, you will go in there with your square footage, and it pops out for you either utilizing the equation or actually going to the chart that you come up with the number of journey daily and peak hour is the one that you're interested in the analysis. And so that's just a sample of the lead generation calculation. Then since your project is mixed use means you have both residential and commercial development. It is not natural to assume some of the folks that live within your development may shop in your development or work in your development. Those portion of the residents not impact the surrounding street system. So you, as an engineer for developer, needs to capitalize on that, and that's where the internal capture comes. What percentage of your journeys will not be property? Page 14. What percent they are is based on the size of the residential, size of the retail, or commercial. You will utilize the generation volume 2 and those sheets and data has been given to you in the handout. So you calculate your internal capture. As a bot, it is obvious when you are having retail on major roadways, there are folks that when they left their home, they're not intending to stop at the facility. However, when they see it, they may come in case of fast food or a bank or such, and they come in the way to work. So those are unplanned visits to the retail side of the development. We call the passing out. So this is a sample of what type of land use will attract passerby. Of course, things that have low duration, activity that have low duration time-wise, attract the biggest number, bank, fast food, and such. So that gives you an idea of what was So here, this is just an illustration of what could be. The dashed line is number of journey before your site was developed. So people would leave their home, come to office, people would leave their work and go to gym, for example, all of a sudden they will see your development here with the Bank of America, just in the way home, stop, get some cash, go to jail. I'm going to home to work, let's stop here, pick up a baby. So those are passive value. That's the concept. Very simple. Now the calculation is not quite that simple. And I want to walk you through this example. So we have got a site, and let's assume it's PM. Rush hour, peak direction is this way. 1,000 cars going this way, 200 going that way. We go to our ITE for passerby based on the type of development we have. It tells us 15% of our attraction are coming from passerbys. So, and then based on a trip generation, we already calculated for our side, we have 400 total cars during peak hour, with 200 coming in, 200 going out. So 15% of these are coming passerby. So 15% of that, 15% of those is 60, 30, 30 entering, 30 exiting, making 60. That's step B. Non-passerby, the graph that we shown you, that we have given you, got your distribution map, show the percentage of vehicle going certain direction coming in and out of the parcel. That is given, but we have
It's only one for
only one. So for this particular site, we've been told 80% of the traffic comes and goes from east, 20% is coming from the west. So that is given. This is from regeneration. This is from passerby table. Here, as far as passerby goes, since our volume, this a lot of what this 17% is 200 plus so total is 1,200. How many of them? What percentage of them are coming from here and going that way? Is 1,000. So 1,000 over 1,200, which is 83%. That's that 83%. From this direction, 200 over 1,200 is equal to 17%. That's the 17%. So we got that. Now we got to break it down into, so total that comes with 200 passerbys. I have only 170 coming. So 170 times 20% is 34 that coming this way. And then on the other direction, 170 times 80%. This here that comes from that side. Are we lost? Who is not? Who is? Okay. So that 170 is basically 200. That is total minus passerby, which was 30. So the 170 cars coming in and going out are not passerby volume. So we are not dealing with 200 anymore. We are dealing only with 170. And we know 20% of them are coming this way, 80% coming this way. So 20% of non-passerby, 170 coming this way, 80% of them are coming that way. Is that better? I see some nodding. I see some big question marks. Now, let's deal with passerby. We had 30 passerbyers coming in. 30 times 17. You remember the calculation? 17. Percent here. So that's 5 cards. And then coming from this direction, 30 times 0.83, 25. So 25 come from this way, 5 that way, total 30. My interest going at 25 and 5, that's my exiting 30. So I have that. Now we do math. It was 200 total. If you add 25 and 34, these are passerby and non-passerby. 59. 5 plus 136, 141. And then coming this way, just add this figure, that would give you that. Then when you subtract that from your 1,000, would give you that. Plus your 200 that you are generating. So that basically is your final volume after you take into account for passerbys and your generation. If you have further question on that, should necessarily email and give it forward.
I will be doing this exact analysis for your insurance. So.
Absolutely.
It will be those exact figures, it will be numbers that you develop based on site-specific stuff if you want to go through this.
You need to understand the concept. And it, it's that rather logical. There's no magic about it. It's just common sense. Yeah, so we've given you that, we made it easy for you. We've given you the solution from computer output. The computer output, if you look at your side, when you add those two numbers, they are 100. Basically, it looks something like this. That being your side. And here is just a bunch of string. So coming, if you add your side, just so there is X number, X percentage that goes this way, 1 minus X, that goes that way. Then they get to here, 1 minus X minus A goes through 1 minus X minus T goes this way, and then 1 minus X minus C goes that way. So basically, all percentage of the card coming out of here are distributed all the way out to a point that the number that percentage gets so small that it's insignificant anymore. But you're only concerned with the intersection that contribution by your project is causing an impact. So chase the big percentages that bottom line. We done this actually last term. We had a site with Zenwood and Papa. We did a manual. And in future, you get a job doing this, and the model is not available for your area. It's so marketable that you can make certain assumptions on where the fund happened. So here is an example. Here is the site, and that shows you what percentage goes each way. And then these numbers, as you move away from the side, the numbers are getting smaller, right? It makes sense. Just splits. And then you basically are concerned with the areas that these percentages are high enough to make an impact. This is the manual distribution. So once you have those percentages where they're going to go, you already know what the total is in sheer number, in the number of cars. You use those percentages to distribute your tree generation volume. Background, so you go to Orange County or FDOT site and get the current year volume for the state of 50. But the volume won't be the same in 2018 when you open your project. So there are 4 years, give or take, of natural growth. And the way to predict what that volume is to use historical. We use historical. So you will go to that site, to the Orange County site and that site. For that count station, you look at the pattern for the volume over the last 15, 20 years. You will plot them out or use some kind of blend analysis. So they look something like this usually, not exactly, but then there's a little of this go on. So this is here, and that's one part of it here. So the slope of this line is your annual growth rate, average growth rate. Now, this will not be acceptable for this course. You need to eliminate anomalies. We had an anomaly in this country, in this county, from 2006 to 2010, 2011. Economy sank, construction came to a halt, volumes went down. So when you pull the data for the state of 50, it probably looks something like this, with this being 13, 12. So you're going to have 2007, 2010 thinking. I want you to discount that when you do your calculation. A national average for annual growth rate, 2.5%. If your calculation does not reach 2.5%, you need to justify why not and what you propose to use for your AGR that is more reasonable. That was an issue in the past when we have done this course. As you see here, there is an anomaly in year 9 that we would discount that. So, background is what is existing plus growth from now till open. equal to project objective. Okay, facility has 36,000 ADT, average annual daily in 2014. We opened the road in 2018. It goes to 5% growth annually. In future is equal to present time 1 plus I n. Future is equal to 3600, 36,000 times 1 plus 0.5 to 4 years. When you do that, give or take, you come up with 40,000. That's the concept. So that gives you that. Then you would do projected roadway segment LOS. Now to this here, you need to add your project contribution. This is pre-development or background. And then you come up with a pre-project, post-project, or opening year. That's what your before and after analysis is to tell us what the impact is. Right? Yes? No? Maybe? So this is a sample of the protected condition LOS, level of service. Here is the projected thermic movement after you subtract passerby, you subtract your internal capture and the passerby and such. And then if level of service has deteriorated based on your development, you need to come up with a mitigation plan. Mitigation plan is or you could say my project cost 5% of the deterioration of stable. How much is the cost of the slope? 50 widening from relative broke down to your side. Here is the segment that has failed because of your development. You estimate what's the cost of sustaining that, multiply it, you contribute 5% to the variation, and that's your fair share cost. There are very creative ways that us engineers negotiate and minimize the cost impact with the developer. And some of them are listed here. But I don't think you will have that situation in good place. So here is a sample of the mitigation plan and the cost estimation for that. Site access and circulation. This is where we get into geometry design a little bit, not too deep, but just enough for the purpose of your site development. These are some of the issues that you should address. Those are all what is the local standard at FDOT, the access management classification for that facility, all can be pulled out of FDOT site. For your thing, you need to show you a chart example of how to desalinate water, the fuel storage, driveway, the site distance, and then lastly, Six Sigma water business. So these are just some guideline steps per se that you need to address. And here are sources for left turn warrant and right turn warrant. I have provided you the sheets from NCHRP 279, and there they are. You enter this chart with schedule 50 volume and your volume, and based on where those two volume intersect, it tells you whether you don't need any depth treatment, and that be as such. And then lane will have that information, or you may need depth treatment. Could be that continuous, or it could be a taper. So that's that gives you that tool to evaluate that. Here is another simplified version of that. This is same thing for the right lane, whether you need to add a right lane or not, based on the cars that are coming out of your development or going into your development. Basically, you need two volumes. This index from FDOT gives you guideline as dimension of the storage and the paper. So use this in getting out your entrance and exit your site. This is some setback for your building, above and beyond what Ray has already spoken to you about. This is just for safety and site distance, how much setback. That's the right side. The left, the right, you can put an arrow here in metric and in English. You'll be operating at right about here. So it's not too bad.
Typically, they're gonna wanna see that on a landscape plan to make sure you're not putting brush, shrubs and trees and things like that will obstruct the view, or a sign, entrance sign or something like that.
Your force main, your pumps, usually most man development engineers start to put those main instruments for easy to get to and stuff like that. The pump station, the lift station. Keep those out of that area. One thing I want to bring to your attention that was a problem with two things last year. This area here is the main entrance, different part of coming going out. Be careful as far as the circulation. How do you lay out your parking, and how far is the internal driveways here? My point is, if you have a driveway that comes in here and you have queue stacked up in here, you're going to cause another bunch of problems there. So if you can allow these cars to come out further and join the maximum back of the queue and take this conflict out, just okay, so signal warrant. You cannot just arbitrarily go and say, hey, my intersection is going to operate best if I put a signal there. They don't just give you a signal. You have to go through this signal warrant. But due to your project being proposed and not having 8-hour volume down, 4 hours down, but as TIA, we do an analysis peak hours, so you can do this warrant and see whether the signal is warranted. And the form that we use is this one here. Please fill the form completely. City, county, main street, major street, number of lanes, what is the average the approach speed, put the main street volume, put your development volume, and make sure you read the discount. There is a lighter version that is this one, 70%. See whether your project qualifies for that, because it's easier to get a signal under 70% volume. That's it. And I think I had some. Okay, yeah, we go to the last part. As we said earlier, this is the most read one. Be concise and good summary of what you have done in the. If there are any mitigation or any improvement you assume in doing your post-project analysis, this will be a place to outline that. And then, for sake of others, if you observe any unusual or noteworthy conditions require attention, that is where you bring them up as well. For example, as far as this one case, very fresh in my mind. We had a development that there were no median opening for the cars, and we ended up with the right out. But through our process, we realized there is a proposed brick and mortar and retail coming across, and they are following us, and we were able to negotiate median opening with DOT and relocate a couple of median openings here at the back. So that's where the things like that come out. So these are some of the things that Mr. Ray has already gone over with you as far as your development, what the type of land you use and such. You can do that. You will do all of these as part of EIA. That's just a good outline. Here are some really relevant links that you can utilize for various components of the EIA. Your improvement, that improvement come from here. The DOT, we have some data. Anything to do with NCSRP 276 comes under that. That's it. Any question?
Dr. Marani here he's the traffic expert, so I can answer some of the questions, but I'm not the detailed expert, so it's best to ask him now. If there's questions as you develop the project, obviously you can email me and I'll forward them on. He'll be grading the traffic submittal. He'll be back at the end of the semester when we do our final presentation. So you're going to be presenting to all of us. He'll be asking you questions on your project at the end. So and he'll be grading the traffic portion of the final report too. So is going to be involved. So feel free to ask questions if there's something you're confused about right now. If not, we'll pass it along as we go on. I've got some other things to go over. So you're not done yet, but Dr. Gerard is. Thank you. All right. Now, I do like to go over this because it's one of those ones that everyone gets tripped up on. And it is a big important part of your traffic study, so
Yeah, HCS has got to use the computer line right there.
yes.
Yeah, it's in there. Huh? What, you like cold ones or much better? Yeah. You're asking about this though. I probably understood about 10% of what he said in my 2 transportation classes. So there's a lot of new material.
Alright, so you never have both.
I forgot he said that. I said I don't like it to laugh.
Oh, did you say that's us?
Alright, that's now.
Okay, so this was in the PowerPoint presentation. But every semester, this trips everyone up, and I think it's worth going over just so you understand what's going on. This is because we're a mixed-use development. There's going to be internal capture. So people that live in the apartments may travel over and go to your shopping center. They may go work in the office. People in the office may go over to the shopping center and shop. Basically, these are trips that are generated for your project but don't actually make it out on the road. So you need to estimate those in order to properly do your traffic analysis. So you've got this triangle which helps you determine how the trips interact. And then you've got this sheet that tells you what percentages interact. So this is on the web course site. I've sort of gone through and done an example. I don't know how legible this will be from the back of the room. But for this example, I put office use up here, retail use down here, and the residential use there. These numbers here, you estimate from ITE. On web courses, there is this document, which you'll need to do your traffic study. This shows you where the site's located, which you already know. This is the model that he was talking about. So your site is sitting right here where this black dot is. This is 50. So when you come out of your site, 81% of the trips are going to the south, 19% are going to the north. Once they sit here and hit Triota, 16% go to the west, 65% continue on. So this is going to be important for once you've calculated your trips, you're going to have to distribute them out onto the roadway network. So this will help you do that. Then you've got these. This is the ITE. This is how you actually calculate the trips. So, for instance, your office building. There's two ways of looking at this. You've got an average rate here, and you've got an equation. Generally speaking, if this R squared is about 80 or greater, you're going to use this equation. Otherwise, you can just assume the rate, or if you read off of it, come up with what you think is a good estimate. But this ITE here is for your office for average vehicle trips per day. So this equation is based, and it's important to make sure you see X is based on 1,000 square feet. So if you've got 50,000 square feet of office space, you put in 50 into this equation. Make sure you note that it's a logarithmic equation when you plug it in. But based on your square footage, you put it in this equation, it's going to jut out how many trips you have on a daily basis. This is the peak hour. Then you've got the same thing for another one. Peak hour again. Then you've got apartments. And there's apartments, shopping center, and office. They're all in there. Okay, so with the ITE numbers that you just got there, you will calculate these numbers here. These are the raw data. It basically says your office building, in this example, generates a total of 2,000 trips per day. Office is 400, retail is 2,000, residential is 200. Those are just numbers I made up, so use those in this example. Since I'm looking at a daily estimate right here, logically speaking, over a total day, whatever comes in also goes out, and it also tells you that on that sheet. If you go back in ITE at the top, it'll tell you during the daily trip what percentage is in, what percentage is out. For daily, it should be 50-50. Peak hour, it may be something different. It may be peak hour 60% in, 40% out. So if you get a total of 1,000, you have 600 in, 400 out during peak hours. So just make sure you pay attention to that percentage when you're doing this for the hourly data instead of the daily data. So you've got 2,000, which is split 1,000, 1,000, 400 split 200, 200. Residential 200, which is split 100, 100. You now want to know what percentage of that is not actually coming from the roadway. What of it is internally generated? So that's where this part comes in, and this sheet. So you've got table 7.1 on one side, table 7.2 on the other side. So if we start down here with retail, if I want to know from retail to office, what percentage of my trips are captured there for a daily trip, I look at 7.1, I go from retail to office. For daily, it's the last column there, it says 3%. So I go from retail to office, so this arrow here on the right, you see it's going that direction. Boom. So from retail to office, 3% of my trips can be captured. Since there's 1,000 exiting, going from retail somewhere, that 1,000 times 3 is 30. Make sense? You then go through and do it with the other. From office or from retail to residential, daily is 11%. So from retail to residential, I've got 11. 11% of the 1,000 that's exiting is 33. I write 33. Actually, I'm sorry, it's 110. I write 110 right here. Then you do the same thing for the other uses. If you go office, exiting from office to retail, that's the first one. Office to retail, you see it's 22%. I wrote 22% here. That's 44. So you go all the way around for the different uses, and you'll fill out everything from 7.1, which is going from a use to another use. Then you flip the page over, and you do 7.2. Now you're going how much a use can accept. So this is how much you can send to office from residential, for instance. So if I go to office from residential for daily, nothing. To office from retail for daily is 15%. So if I go office to retail, so again, office, going out of office to the retail, I can send, actually, I'm sorry, wait. This is to office from retail, so it's this direct, it's this side. It's 15%. I wrote 15%. 15% of what's entering, so 200 times 15% is 30. I've got 30. So again, this is what's coming into the development. So 7.1, I'm going exiting the use, so I'm filling out this column. And 7.2, I'm looking at entering the use, so I'm using this part of the box, so this box. Does that make sense?
So that again?
When you do 7.1, this is going from a use to another use. So if I've got labeled retail, I'm going from retail to office. This arrow here is going that direction. So from retail to office, I fill in this box. When I flip the chart over, use 7.2, I'm going to office from retail. So I'm going to office from the retail. That's this top box. That's the 15%. So that fills in both of those numbers there. That makes sense? So now you go through, you fill out all these boxes. And then you look, and this is just telling you what it's capable of sending. It's not saying what it's actually sending. So what this is saying, now that I'm going to look at it, I say retail has the ability to send 30 trips to office. Office has the ability to accept 30 trips from retail. They happen to be equal in this case, so I write down 30. Down here, though, I've got retail has the ability to accept 40 trips from office. However, office has the ability to send 44 trips to retail. You can't take more than you can receive, so since the max you can receive is 40, you put 40 down. Does that make sense? Yes.
I have a question. How is it to office from residential when there is value non-applicable?
So which one is that? To office from
So
residential?
7.2, to office from residential.
Yeah, I guess theoretically you think there'd be something there, but for whatever reason they don't calculate it there. So we just have to use what's on the table. Pardon? That's true. So you go through and do it. So you can see here you've got 0. They're both 0. It doesn't matter. This can take 3. This can send 4. Since you can only take 3, that's what you got. Any of them widely, this is the biggest disparity. Retail has the capability of sending 110 trips to residential. However, the residential use only has the capability of receiving 33. So it doesn't matter that you can send more. The max you can receive is 33, so you write 33 down. So now then you take all these numbers you got in the center and add them, or actually you can put them right here. So this is saying internal capture, the center column, entering, I have 30 trips captured. So if I look entering, I've got 30 plus 0 is 30. I write 30 down. Exiting, I've got 43 written here. That's 40 can exit, 3 can exit. That's 43. For a total of 73 trips are captured internally. Same thing down here for retail. I've got going out of retail. I've got 33 trips going that way. I've got 30 that way. So I've got 63 trips exiting that are captured internally. I write the 63 down. Coming in, I've got 40 and 38. That's 78. So I've got 78 trips that are captured. So what that's telling me is, even though ITE is telling me I've got 1,000 trips generated by this development, 78 of them are internal to the use. So they're not actually out on the roadway. So I'm not adding those trips out on the roadway. There's no impact on the roadway. So I subtract that 78. I've actually only got an impact of 922 trips on the road. That's entering. Exiting, I only have 937, which is 1,000 minus 63. And then when you look at total, of the 2,000 trips total that ITE says this use generates, 141, which is 78 plus 63, are internally generated and captured. So you only really have an impact of 1,859 trips. So this is just summarizing it all. These numbers here are just land use A, which is this. That's just those numbers repeated. Land use B, that's those numbers repeated. Land use C, those numbers repeated. Add across, come down. And now if you take this 2,600 trips, which is the total versus, this is the actual total minus the reduced total, you'd end up with 11% internal capture overall through development. So if you just hand you these tables, you probably get very confused. This example is on web courses. That's just sort of a quick overview. Does that make sense to everyone? So that's the first one that's going to reduce your trips. The second, Dr. Marati went over, that's pass by. I think he explained it well. Does everyone understand what pass by means? If you're driving into UCF in the morning and you decide you're going to pull into Starbucks and get a coffee before you hit campus, Starbucks did not cause you to be on the road. UCF caused you to be on the road. So it's not fair to charge Starbucks with that trip. So whatever percentage you have of pass-by trips, you can reduce from your trip generation. And Starbucks is a very good example because there's a lot of people just driving by who are going to pull in Starbucks. Fast food's another great example. Not many people hop on the road with the intention, I'm going to McDonald's and I'm going home. Normally it's, I'm on my way somewhere, I'm going to pull into McDonald's and then keep going. Or wherever it may be. So McDonald's would get some sort of credit in that situation because they're just taking advantage of the trip that's on the road. But let's make sure we get an understanding again. Yeah, I want to do something. Okay, so just go over this one again because this is sort of important. Every one of you will have something almost identical to this in your final report. You've got your retail uses. These are just the ITE codes for the land use. This is just summarizing, this is the rate, this is the unit of that, and that's basically if you took this unit times this rate is going to give you that many trips. So this is how many trips ITE says that use generates. You then get to reduce each of these uses for internal capture and pass by. So in this case, for this development, it had a total of 17,718 trips based on ITE. Based on the internal capture, that's the example we just went through, it said that development had 5% internal capture. So you take the 17,718 by 5%, that should give you 886. So you can reduce those trips by 886. Retail pass by is 34%. That's also from ITE. That's in the handout that's on web courses. You can determine what that is. But this only applies to the retail use. So this retail use, which is 8,365, you can reduce that by 34%, which should be the 2,712. That should be 34% of 8,365. So you've reduced the retail by that. This one had drive-through bank, which had a 47% pass-through. If you think about it, that makes a lot of sense. The drive-through banks, a lot of people are just on the way home, they're swinging into the ATM, going to the tellers, they pull in, leave, they're not actually going in. That wasn't their destination. It was an errand they ran on another trip. So you can reduce the bank trips, in this case, which is 2,366 by 47. If you go through this whole example, it ends up that 17,718 trips gets reduced down to 9,883 trips. Then this just sort of distributes them out based on your in, out, and total. So a certain percentage of those are going in, a certain percentage are going out, and you got a total of those trips. Does that make sense? You're gonna all have a chart very similar to that in your project. All right. I think that is it for my discussion of transportation and Dr. Marati's discussion of transportation. So if you have questions, shoot me an email. I'll pass it on to him. Now we got the quiz, which y'all shouldn't be a shock, but it is a